To understand RAG, let's play a quick game with ChatGPT. Let us ask it who is the current US president, but it's not allowed to use web search. So the answer it gave was Joe Biden. But we know that's incorrect. So let's ask again, but this time we enable web search. So it answered Donald Trump. But what happened? Why did ChatGPT give me two different answers to the exact same question? Well, the answer is something called a knowledge cutoff. These huge LLMs are trained on massive amount of data. However, they are trained on data till certain time period. For GPT-5, its cutoff date is 1st October 2024. It means if you ask it any question beyond this date and it doesn't have web search, it will not be able to provide you latest information. That's why it answered Joe Biden in the first attempt. However, when we enabled web search, ChatGPT could retrieve latest information, augment it with our original question, and generate the correct response. And this is what RAG is, Retrieval-Augmented Generation. And now let's understand how RAG actually works. So you start with the knowledge base, which is a collection of your documents. This knowledge base is connected to a retriever. Now we will see how this retriever is used. When a user provides a query, then this query is passed on to the retriever, which searches this entire knowledge base to find the most relevant documents relevant to this query. Once the retriever has found these relevant documents, then those documents are combined with the original user query to create an augmented prompt. This new augmented prompt is then sent to the LLM, which generates the final, more accurate and up-to-date response. And this section represents the entire RAG system. But how is this retriever able to find relevant documents? Let's see what is happening under the hood. Your knowledge base consists of multiple documents which are passed to an embedding model. The purpose of this embedding model is to convert each of these documents into vectors of numbers, also known as document embeddings. These embeddings are then stored in something called a vector database, so that we do not have to calculate these embeddings again and again. This vector database is connected to a retriever. Now when the user asks a question, let's say who is the king of the UK, then this question is exposed to the same embedding model which was used in the knowledge base. So we get our query embeddings. Now these query embeddings are passed on to the retriever. So the job of the retriever is to find the most relevant documents for this query. Let's say in the vector database we have 4 different types of documents comprising of UK news, pizza recipes, UK monarchy and British food. The retriever will calculate a similarity score of the query embeddings with each of the document embeddings. Next, once it has calculated these similarity scores, it will find the documents with the maximum similarity. And then those will be our top K relevant documents. There are so many benefits of RAG. Number 1 is cost. Retraining a giant LLM to get latest information will be insanely expensive. However, with the help of RAG, LLM providers can connect to latest information, so we users can get up-to-date answers. Next is access to proprietary data. So you might have many documents which the LLM has never seen during its training because they might be your internal documents like company policies, technical documentation or customer data. So with the help of RAG, you can build chatbots so that you can ask questions from these documents. And the last is verifiable sources. So when an LLM is answering questions from its memory based on its training data, it will not be able to give you any references. However, when you are using a RAG framework, LLMs can actually cite where they got that information from. So you can cross-verify in case you would like to. So if you found this video useful, do like and subscribe to support new content creators like me. Until then, see you soon.